Hello, everybody. My name is Peter van Eyck, and I am one of the world's most experienced independent cloud computing trainers. What I want to do today is talk to you about why cloud computing is the future of IT and why it is the future of your job in IT. And IT has always been a pretty dynamic environment, but cloud computing may well be the biggest change that the industry has faced so far. So before I continue, I want to let you know that I'll be having Q&A at the end of this and an announcement of a checklist and roadmap at the end of this. So what do you think? Is cloud computing the next wave in information technology? Is it a load of marketing hype, or is it a jump into the deep? Well, to be honest, I think there's truth in all of these, but I think that cloud computing is mainly a state of mind, a way of thinking. And so I'm assuming that your job, that you work with IT, that you're an IT system manager or solutions architect or any other role, or you're involved in procuring IT or on the legal side of IT. And I want to know a little bit about what you do. So I should be having the poll right now. Start voting, right? Is the company that you work for or consult for predominantly a cloud consumer or a cloud provider? And I'm going to have this open for a few seconds. Half a minute, that is. Let's see what's going on. Right, so we still have a few moments to to vote. And we're going to keep this open for another 25 seconds. And counting, still people are voting. So are you a cloud consumer predominantly or a cloud provider? And I understand that you could actually have both roles one way or another. And I'll talk a little bit more about that in a second. So on the call, apparently most people are working for a cloud consumer. Now let's have a look at the next question then, which is what most accurately describes the majority of your work. What I see is that people are either designing, creating cloud solutions, or working with cloud to create other IT solutions, or they are in a assessment or validation or risk assessment role, or maybe in securing that cloud stuff. And the third role is to manage that stuff, to manage cloud and IT solutions, which is like the ongoing management. And then, of course, you can do something completely different. And if that is the case, I would really appreciate if you drop a question or put it in the feedback, as a matter of fact. Put it in the feedback section. There should be a feedback section that gives you the opportunity to drop a comment in there. Right now, it seems that most people are in managing cloud and IT solutions, which is interesting because my typical audience is more interested in assessing and securing that stuff. So that gives me some idea of what the audience, what you are all about. So to understand the future of IT, we must first understand the past, because if we don't have that history, then we are doomed to repeat it. Now, my slides are flipping back and forth, but you could see the mainframe, which was the first commercial application of IT. This is a single computer filling a large room, an entire department running it, and serving an entire company. And this is the kind of hardware that I wrote my first computer program on in 1973. But a lot of stuff has happened from there. And in the 80s we started, in the 90s we started getting client server, where basically every department had their own computer, and each computer had its own system manager. So ownership changed a lot from the company to the department. And that also made a lot of impact on the way decisions were made on computing. And it's not just about technology, it's about the way that you decide on IT. Then we had the internet and the PC. And one of the things that happened there was that companies no longer owned all the computers that users worked on. We moved stuff to customers, and they worked on their own computers. And people at home owned them. Again, a shift in the way ownership and responsibility was organized. And then we get the breakthrough of cloud computing, where companies no longer even own the servers that they work on. And one way of looking at this from a management perspective is who runs it? Who pays the electricity bill? Is it a central department? Is it each business unit? Is it the user? Or is it completely outsourced to another company? And in a few minutes, we will have a look at how the amount of people changes that we need to run one computer. And just remember that it took a whole team to manage a single mainframe computer. Now, each of these steps, mainframe, client server, PC, cloud, is a disruptive change. And the whole idea of disruptive innovation is not just a marketing word that's being abused for that. It's a solid business innovation concept, and it's developed by Harvard Business School professor Clayton Christensen. And according to Christensen, and I'm paraphrasing a little, now I'm getting a message that we cannot see in the video. That's weird. Well, I'll have to leave that to the BrightTALK management. I'll make it clearer then. Okay, let's prioritize that. So according to Christensen, a disruptive innovation is something that is not as good as initially as the thing it replaces, but it is much cheaper. So it appeals to people who were overserved by the original product, so who couldn't afford the original product. And because of this, there is a business model, and that business model allows that company to innovate further. And it can be improving and rapidly improving, and in the end, it will overtake the original and drive it out of the market. Now let's get to some of the examples here. And the first example I want to share with you is Wikipedia. Now, the first version of Wikipedia, was that any good? No, it was just a handful of articles and nowhere near the completeness of the, for example, Encyclopedia Britannica. But it was good enough for a lot of people, and it was definitely a lot cheaper than the Encyclopedia Britannica. And fast forward a couple of years, and which is the one that survives? Is it Wikipedia or is it the Encyclopedia Britannica? The PC is another example. The original PC was a really simple machine. It had only 64 kilobytes of memory. I remember that I saw one and I was thinking, hey, you cannot take this seriously. This is not a real computer. It can't even multitask. 64 kilobytes? Are you joking? My bootloader was even bigger than that. But the PC has innovated and innovated and innovated, and we now have come to the point that your average server is a souped-up PC that is more powerful than the mainframe that it replaces. Now that's what we call a disruptive innovation. And then, of course, we have the internet replacing leased lines at a fraction of the cost, and the next thing up, cloud computing. In the beginning, it did not sound like much, but it has evolved and evolved and evolved. And right now we have to understand that cloud computing can actually be better, cheaper, and safer than the style of computing it replaces. A few years ago, for example, I was measuring the uptime of cloud services, and back then they were already better than most corporate IT. Now, each of these disruptive innovations has something that you might call a tipping point. And for a long time, the world is on one side, and you're happy on one side, and suddenly, like a seesaw, it has tipped to the other side. And once it passes the threshold, most of it suddenly moves to the other side, and you go like, hey, what happened? And if you are one of the people whose job is involved in that change, you can complain about it. I mean, you can say, hey, it's a change for the worse. The mainframe was such a good machine. And you can start complaining about it, you can keep complaining about it, or you can try to find out what you've learned in your last job and carry that over to the next generation of technology. I think you can do that, but that is a different story. So the end result of this for IT is that it's not your daddy's data center anymore. You know, that big fortress on the hill, protected by a large moat and big walls, it is no longer there. This is no longer the model for IT. Digital data is no longer confined to the walls of the data center. It is the whole world that's being connected. And all your systems are basically plugged into that giant worldwide grid of interconnected machines. Now, what makes these developments happen? You know, what does happened that created that move from your daddy's data center to this connected world? Well, the biggest driver for information technology is Moore's law. Moore's law, where where we can see that just about every 2 years the number of components on a chip doubles, and as a result, the capacity in terms of processing and storage increases by more than an order of magnitude every decade. And in my lifetime, I've seen the price-performance ratio of computing, storage, and bandwidth improve by at least a factor of 1 million. And that drop in price goes hand in hand with an increase in the amount of IT stuff that we have to manage. I mean, we're spending the same amount of money or more, we're getting more bang for the buck. So the amount of stuff that we have to manage is orders of magnitude more than a few dozen years ago. And what does that mean for the number of people that have to manage this? Is that increasing by orders of magnitude as well? No, it's not. It cannot. We don't have that many people. So the productivity of managing that IT really has to go up. And it actually does go up. If you think back of the story I gave you earlier, we started out with like 10 people managing one computer. A little later, it was one person managing one computer. And then we had one person managing 10 computers. And now we see that for specific functions, people are managing thousands or even tens of thousands of computers. So that productivity has to go up. And at the same time, we need a lot more skills to run that stuff. We have more technology, we have more components, we have more programming languages, we have more interfaces, we have more devices, we have more existing software, and our IT is having more of an impact on business and society. From the back office, it expanded into the front office. And from the front office, it moved to being the product for some companies. Think Netflix, Uber, Airbnb. But just about every company cannot go back to manual order taking or production control. And the threat landscape, in terms of the number of people that are trying to hack and abuse that technology, is also increasing rapidly. And not to mention their skills level. They are also increasing. So that means that we have to have a lot more brain power to manage all that, a lot more brain power. And it is no longer feasible to run that IT entirely in your own shop. We need a way to organize IT that does not force us to deploy 100 skilled people for a 100-person company. That doesn't work. So let's have a look at how that problem has been addressed historically. Henry Ford allegedly invented, or at least made big, the assembly line method of automobile production, where a lot of people were working on very specialist jobs in that assembly line. And that made productivity really go up massively. In IT, it is no different. We have specialists for just about everything. Network engineers, server and storage admins, database administrators, front-end and back-end developers, and so on and so on. But the parallels go much, much deeper. What you see here is the River Rouge plant where Ford had the assembly line laid out. It was built between 1910 and 1920, and it is still there. The River Rouge plant was the first full assembly line cranking out cars. On one end of the factory, ships would come in with iron ore, and on the other end of the factory, T-Fords would come out. In between was the assembly line and everything needed to produce the car. The Ford company had its own steel mill, had its own electricity plant, had its own glass factory. Everything was there on the River Rouge plant. At that time, it was the largest industrial estate in the world. But after the assembly line was introduced, other changes started happening. Fast forward a couple of decades later, and this plant is no longer exclusively owned by the Ford Motor Company. What happened was that division of labor was extended beyond the company. Components of the whole factory were outsourced. The Ford company no longer owns the steel mill. The steel mill is outsourced to other companies, to another company with more steel mills. It no longer owns the electricity plant. That is now part of a large electricity company. Again, we see specialization. This time beyond the borders of a specific company. The assembly line has now become part of a supply chain of companies, each of which delivers to the next company in the flow of goods. And the result of that for the car industry, the automobile industry, is that the specialization of labor above the level of an individual company makes that only 20% of the value of the car is produced by the car company, and the rest is outsourced. And the same has happened with other companies. For example, Apple. What we see here is the original Apple I computer, which was developed around 1976 by Steve Jobs and Steve Wozniak. And the first order they got was 50 by an electronics shop, and they had to solder these together in the kitchen table in Steve Jobs' parents' house. Right? You could say this was the original iPhone, but it was a little less functional. Fast forward a few decades, and this is what the iPhone supply chain looks like now. Right? That supply chain is now around the world, and Apple no longer manufactures iPhones, contrary to popular belief. It is all outsourced. The only thing that Apple does is design them or market them. Have a look at the back of your iPhone if you have one, and read what it says in the fine print. These things are produced in global supply chains. But global supply chains also create their own new problems. In a supply chain, we can no longer fix production glitches by having one department head talk to another department head. Like in Steve Jobs' parents' home, they moved the stuff to the living room to test the boards, and if it didn't work, they just sent them back to the kitchen. In a supply chain, you have to have much more control. The supply chain has to be controlled in a more explicit way. And I ran into an example of that last year when I was delivering a course in Tunisia. At night in the hotel, I was chatting up with a German guy, and then it turns out that he was there to audit the supply chain of a big German car manufacturer. And the company in Tunisia was producing a part of the electrical system of the car, and not even the whole electrical system, just the cable that ran from the battery to the body of the car. And the guy that was out there to audit their process, and he didn't even look much at the product. He only looked at the process. If the process is good, he said, the product will be good. And he was coming back every couple of months or so to audit that part of the supply chain. He also explained that if this company stopped delivering, the assembly line in Germany would stop in 48 hours. So there were really strict delivery agreements, and they got fines if they failed that. So the upshot of that is that today's car is not only cheaper comparatively, it is also more fuel efficient, it is more functional, it is safer, it is better in all dimensions, and you can even get it in another color than black. And this is how specialization of labor in a supply chain works. And with cloud computing, it is a similar thing. Cloud companies basically create an IT services supply chain. Here's a diagram how that might look like in a simplified way. As a cloud customer, you consume services from a software as a services provider. And a lot of these SaaS providers actually have their own, have their infrastructure sourced upstream. In reality, it is a little bit more complicated than that. It more looks like this picture, where you have a ton of SaaS providers. In my courses, I find out that most companies have hundreds of them. And similarly, you have a lot of platform providers, and then it's all hosted on Amazon. Now, I'm just kidding there. There's also hosting on Microsoft, on Google, and a few others. And some SaaS providers actually host it themselves. So there you have it, the IT services supply chain. This is the new model for delivering IT services. It's better, it's safer, potentially, it's cheaper, but it's also more complicated. It has more moving parts. And there are definitely different ways to control it. Now let's show you how this model expands and plays out in this day and age. What I'm showing you here is a mobile app architecture that is hybrid in the sense that it is spread over a company's premises as well as in the cloud, so to say. So the app is on the top, it's on the phone of the customer. By the way, this is a real example. I worked with a company who had this as their architecture. And that phone then talks to an Azure cloud database, but that phone also talks to a company internal database. This is a bank, right? So this is actually a mobile banking application. And To top it off, there's also an app store where that application is in. Now think about this. Um, Are all these components essential to run that app? I think they do. It's no longer sticking your CD in the server and that's the app. No, the application actually requires all those components to work. And each of these components has a different owner, has a different um, party that controls it. And that's true for the cloud side, but for a medium to large company, that is also true on the internal side. So what I'm saying is that this cloud model of IT supply chain is applicable across uh, the entire landscape, not just the cloud, but also internally. And you will be better off managing your own IT as cloud as well. Now, this is driving companies to move into different and into new directions. And we see unconventional new cloud providers coming up. I'll give you the example of Amsterdam Airport because there was a nice article about that recently in a paper I read. So it is a real estate company in a way, and it's not just a piece of real estate. It's about the size of a medium-sized city. It handles about 500,000 flights yearly and about 68 million passengers, which ranks it third in Europe after London and Paris Charles de Gaulle. So it is a significant company, so to say. But it is also a service provider to its users. And the users are airlines, travelers, baggage handlers, ground services, catering services, restaurants, businesses, and what have you. And it is providing digital services to these companies more and more. And I'll give you the summary of that in the next slide, which is that they have APIs that help them enable their value goals. And the value streams that they support are the customer experience, in this case, the traveler. They want to support the performance of the airlines and the airport itself. And the assets have to be smart and more efficient. So talking about air conditioning and building maintenance and all that stuff. So for the customer experience, the objective is to have the customer have less stress and less feeling of lost, and not being queued too much. When it comes to the airlines, the objective is to have fewer delays. And when it comes to the building, of course, energy and maintenance costs are relevant. They have about 70,000 sensors in there. And they provide information on all of that to their partners, because that will allow those partners to actually achieve those objectives. They've done 9 APIs right now, and they're used at the rate of 1 billion calls per year. One example I'm going to give you is that across the building there are boarding pass scanners when you move to the next gate or the next queue, so to say. And that information is collected by the airport and then handed back to the airlines of those travelers, and they will get then better information of where their passengers actually are, and that enables them to perform better in terms of delays, etc., etc. And this is just one small example of the possibilities that exist. So there you have it, the IT supply chain once more. Once we have all this cloud stuff, new things become possible, and new things that might well include your future job. If you think about the existing IT that you do right now, it's going to be done in a different way and probably with less people. At the same time, there will be new things, and that will require new people, more people. So let's have a look at some of them. Once we have programmable infrastructure, which is a thing that cloud does, we can do automated integration, automated testing, automated development, automated deployment. We can do DevOps. And once we have capacity at scale, and I'm talking about real scale, so 1 data centers at a time, we can do big data, really big data. And once we have all that stuff out there on the network, it makes more sense to develop social and mobile applications for individuals as well as for companies. And this is also where IoT lives. And as a result, it has never been cheaper or easier to start a software company or set up the IT for any company for that matter. I reckon, for example, that if you put your mind to it, even with a team of just 2 or 3 people, you can start a company, including its develop and deployment pipeline, in less than a day, just by procuring the right cloud services. Now let's focus on one of these drivers. The one driver that I think is really driving the IT transformation from the business perspective, and that is the DevOps revolution, the top one. Back in the old days, when a new version of software was released, it was released once a year, and it took a while to implement. It had to be installed on all the machines, database, migrated, and so on. Very complicated. But with DevOps, you automate a lot of the entire software development and deployment and pipeline, and this is called continuous integration, or even continuous delivery. It allows companies such as Amazon and Netflix, banks, to deploy new services or bits of new services literally thousands of times a day. And that creates, for their businesses, enormous agility, enormous feature velocity. And that allows them to innovate quicker and better and adapt quicker to the market. And as you remember from Darwin, it is not the strongest of species that survive, but it's the ones that can adapt to changing circumstances quicker. And it's the same for companies. Now, if you are in IT, or your job is related to IT, what are you going to do with this? What should you do? I mean, this is the new world. This is inevitable. In fact, it is already there. And this is the new way that IT will be run. And of course, it will take another 10 years for this to reach 95% saturation. But there's only one way, one direction that this is going. Think about it. We still have mainframes, but there's not a lot of work in mainframes. We still have mini computers, but there's not a lot of work in mini computers anymore. We still have PCs, but there's not so much work in managing those anymore. In fact, we're often leaving that to the users. So cloud computing is really where the new action is. And if you want to succeed in that world, you have to know about the nuts and the bolts. You have to know how it's pieced together. You have to know how to control suppliers and everyone and everybody in that ecosystem that is upstream from you. And you have to demonstrate to the people downstream that you know what you're talking about, that you are in control. You have to know how to control all kinds of risks. And you need to know where you fit in that ecosystem. Don't be stuck. And once you get there, it's a great new world out there. So what do you need to make that transition? What do you need to make that next step? You have to understand cloud business value. It's not just about being cheaper. You have to understand cloud risks, because there are new risks. You have to understand cloud architecture, so that you can most effectively set up new solutions. You have to understand the cloud adoption process, so that you don't get stuck in complicated discussions. And then you have to do the actual cloud risk management, or at least your company has to do that. And then, unfortunately, you also have to know how to manage and understand vendors and their tactics, because they're not always ahead of the game. I'm just finished another training session, and these people have become aware of the fact that they need to tighten the screws on the suppliers a lot more, because they're cloud washing, they're doing all kinds of things that are not in the benefit of the company when you look at it from a cloud perspective. So what I have for you to get you started on that roadmap is a checklist for your next steps. I've created that specifically for this webinar. There's a Cloud one-on-one page, and that includes a few security quick wins. And another one is about cloud certification options. You can follow the link that is attached to this webinar, or you can visit the link that's below here. You can type it out, but you could also potentially have a look at the QR code here, because it brings you into that directly. And that gives me time for Q&A. And I'll happily take all your questions, and I hope that you have some questions, obviously. And I see. I hope that the video problem for one of you was resolved. I would appreciate that if you would comment on that. Let's see, what else can we say? Okay, one of the questions that I'm getting is about individual certification. Okay, so the about around cloud security. Now, the original group of people that got together to think about cloud security was the Cloud Security Alliance. And they created about 7 years ago a body of knowledge, the Cloud Security Guidance, as it's called, and a certification around that, which is called a CCSK, Certificate of Cloud Security Knowledge. You'll easily find that on the internet, CCSK. And then a couple of years later, ISC Squared, who are the organizers of the most famous IT security certification, worked together with the Cloud Security Alliance to create the Certified Cloud Security Professional Certification, CCSP. I actually wrote a part of the body of knowledge there. So if you're interested in demonstrating your skills, I would have a look at those two. You will find that and there's some information on that in the download as well. So, by the way, if you have more questions that I can't answer right now, I'll update the downloads to reflect those. So, getting back to CCSK and CCSP, you will find that CCSK is a little bit more up to date right now, although CCSP will definitely overtake that and catch up and overtake that in the near future. That CCSP is a bit more work than CCSK, but in the long run, it's going to be more recognized. So, generally speaking, I tell people that they should consider doing CCSK first, and then moving on to CCSP. Now, in terms of certification of companies, that is a little bit less mature, although it's getting better. That's a longer story. Some of that is on the download and the endload, but that's about it. Then another question would be, where do we get started on cloud adoption? Well, to be honest, your company probably already did, but not in a specific way, not in a organized way. So there will be shadow IT and shadow cloud, probably, and it will be in more corners than anywhere else. So you would probably want to start with some corporate idea of, let's do this. Let's think about reorganizing IT, and you really need to start with a proper common understanding of what that cloud is going to bring to you. What is the objective that you have by going to cloud? And it's not just cost cutting. You have to have a slightly more fundamental notion of that. And cloud is also not just about moving stuff to Google or Amazon or Microsoft. It's about rethinking how you use IT to drive your company's development and performance. So with that said, I believe we have no further questions. It was great talking to you. I enjoyed the feedback that I was getting. Let me check if some of the things that were going on here. Okay. Yeah, I don't do BrightTALK's webinars too many, very often. So the user interface, I have to explain. I have to browse that. So I see. I guess a lot of people are downloading and looking at those attachments already. So the slide deck is on the download set of links. There is a link to my homepage, and there is a form that you can fill in to request that checklist that I mentioned. If there are no further questions, there's another question. How do you rate the ratio between public versus private cloud? Well, that's a great one. And one of the things to consider is that people are abusing the definition of private cloud these days to mean things that it doesn't mean. And to do a well-organized private cloud is actually beyond the capabilities of most IT organizations. And if the question is, how does the in terms of, if you think private cloud is your current IT, which actually it isn't, I think that public cloud for a lot of companies is still only 10-20% of spending, but it's really going to be a lot more. Then, if that's the question, so to say, and to wrap that up, I also think that there is let's say, a gradual difference between private cloud and public cloud, because you can outsource some private cloud, so then it becomes more like public cloud to some extent. And if you dive into the stuff, it's a little deeper than that, and the guidance of the Cloud Security Alliance gives you a lot more information on that. Of course, you could come to one of my courses as well. Let's see if we answered this. We've answered that one. We have I hope I answered that one. For which audio is a private cloud an interesting approach? I think that's a misspelling or something like that, because I can't completely understand that question. Then the future of network administrator. What roadmap should a network administrator keep in mind? Oh, that's a really interesting one. Now, what we have with network administration in the public cloud world is that all the stuff that you might be experienced in, like setting up routers and switches and IP number address spaces, there's a significant part of that that is disappearing because it is being automated by the cloud provider. At the same time, your understanding of those topologies and your and the IT security, the infrastructure security concerns around that, if you study that properly, then you'll see that it can carry over to the functionality of an infrastructure as a services provider. And you would, once you understand that, for example, you could have a look at, for Amazon, there's the associate solution architect. That will be a good start. Microsoft has something similar. Then you learn how that works. It's more software-defined networking, which is a different story altogether. And designing that and automating that design, that's where you need to go. Now, if you think about network administration in a wider sense, including servers, again, you would have to look at what infrastructure as a service providers are doing and how they are scripting and automating things. And there are tons of provider-specific courses. So, depending on what's going on in your company, it will be wise to have a look at that as well. So I guess I covered most of the questions in the Q&A. It was fun getting them, and hope to hear more from you. You have my links, and just stay in touch. And if you have any more questions, just put them as a reply to whatever message you're getting from me. And enjoy the rest of the summit. I know there's some great other presentations out there. I've seen a few, and it is really a good way of advancing and updating our knowledge. So thank you, thank BrightTALK, and have a great day.